So in this video, we're going to be looking at the first principles for differentiation, and we're going to start by looking in this first video at why this works, and how we come up with the first principles formula. First of all, I'm just going to start with a basic circle, okay? If I was to add a line on here that intersects the circle just once, I should hope you know that that's a tangent. Okay, we have one intersection point here at this circle. So there's 1 point, 1 coordinate where the circle and the tangent intersect. And if I wanted to work out the gradient of this circle, or the gradient of the point if it was just part of the circle of this curve, I would estimate it by using the tangent and taking that point and then working out the gradient of the tangent. And that's what you do at GCSE. However, at A-level, we have something called first principles, which is approximating this tangent here by using a formula. So if I was to add on some parallel lines here to the circle, we can see that they actually make chords. Okay, we've got a point of intersection there, 2 points of intersection on each line, and we actually get chords on the circle. So as we can see, this makes a chord here, and let's say we called this A and we called that point B. If we were to make the chord smaller and smaller and smaller, we would actually be moving these points closer and closer to each other. Points A and points B would be moving closer and closer to each other. And as they get closer and closer and closer this way, and A gets closer and closer this way, we can see that they are actually going to reach the point of where the tangent intersects the circle. They get very, very close to this point, but it's never going to touch this point because we actually still want a little chord. So what I'd quite like to do now is have a look at that in terms of a curve on a graph. So let's take this graph, for example, where this is our x-axis and this is our f of x-axis, okay? Now we're going to take these 2 points A and B, and it's like we've just took this part of the circle and put that onto our graph. So let's say this point is A, and this point here is B. So here we've got A, and there we've got B. And we know that point A has an x coordinate and a y coordinate, and the same with point B. So if we call this x coordinate here at A, if we just call that x, we're going to label this distance between A and B, we're going to label them h. So we're going to label that distance there h, okay? And what we're now going to do then is we can now work out what our x value here is at B. If we started from A, we're going to have an x value, and then we're going to have to add on h as well, aren't we? Because we've gone from this x value all the way up to the distance h. So our bx value is x plus h. Now what we can say is we also have a corresponding y value for those points. And the y value for our x, well, we just know if this is the curve y equals f of x, as we can see from the y-axis being f of x. When we put x into our curve, we're just going to get a y value of f of x. And when we put our x value of x plus h into the curve, if y equals f of x, and our x value is x plus h at B, then we're going to get y equals f, and replacing x with x plus h, our y value is f of x plus h. So we can also add that onto our diagram. What I can do now is connect the points A and B together to make a chord like we had in the circle. And what I want to do is I actually want to find the gradient of that chord. And the way we do that is it passes through points A and B, so this is just basic working out the gradient. The change in y has gone from f of x plus h down to f of x, so we can work out the difference there by doing f of x plus h, our y value at B, minus f of x, which is our y value at a. And we also know the change in y, which we called h at the beginning of this video. So now we can say the gradient of AB is equal to f of x plus h minus f of x, that's our change in y, divided by our change in x. We've gone from x to x plus h, so that's just going to give us h. And that's part of our first principles formula. But what we've got to remember is, like I said at the start of this video, that A and B never actually reach this point of intersection between the circle and the tangent, because we never want this chord to become 0, the length of that chord to become 0. H can never equal 0, because then we're dividing by 0 and everything goes wrong. So what we're going to have to do is introduce something called a limit. And what is a limit? Well, we said h can never equal 0 because we never want the gap between our point A and point B to be 0, because then we would have no chord. So h approaches 0, and that's our limit that we create. It can never equal 0, but our A and B value get so close together that it's approaching 0 but never actually reaches it. So we have to add a limit on the front of our formula. So we're going to say the gradient of AB is equal to the limit of h tending towards 0, and that's the notation that we use for h tends towards 0. And then just the formula that we worked out previously, f of x plus h minus f of x divided by h. And now we know that the gradient of a curve, if we watch the previous video, is dy on dx. Now that's when we have y is a function of x, the gradient is dy on dx. However, when we have y equals f of x, what we want to say is f dash x, and that's another notation that we use when we're working out the derivative when we're dealing with f of x. So the gradient of AB can be replaced with f dash x, and then we're just going to write down the formula that we've worked out with our above working. And then we can add f of x plus h minus f of x divided by h. And that is our first principles formula.